Welcome to this tutorial on finding the equations of the medians of a triangle algebraically and thereby being able to find the coordinates of our centroid. So again, we have a triangle here with three vertices A, B, and C. We've already taken the time to calculate each of the three midpoints. You should remember how to do that. It's the average x value, so you add them up and divide by 2, comma the average y value. So again, we add those up and divide by 2. Leave things as improper fractions, please. No decimals, no mixed numbers. And we also calculate the slope. Rise over run could work for that. Now we want the medians of each side of the triangle. So let's start with the median of segment AB. Now the median of segment AB goes like this. It goes from the midpoint to the opposite vertex. So what we're going to use is we're going to use the midpoint, which was negative 1/2, comma 2, along with point C, which was 8, comma 11. Now what we're going to need to do first is calculate the slope of that line segment. So remember, slope is y2 minus y1 all over x2 minus x1. Watch for subtracting a negative. Up top we get 9. In the bottom, 8 plus 1/2 would be 17 halves. Use your calculator. We do not want to see decimals. I don't even want to see decimals along the way. Use your calculator as needed. That slope is 18/17. Then we take that slope, which is 18/17, and we use either of the 2 points now. And I'll go with the one that avoids a negative. It's just easier that way. And we'll plug into y equals mx plus b. The y is 11, the m is 18/17, x is 8 plus b. Yes, fractions will be a common occurrence with these items. So use your fractions on your calculator as needed to help you out. 144 over 17 plus b. We subtract the 144 over 17 from both sides, and we get 43/17 is the b. So the equation of the first median will be y equals 18/17 x plus 43/17. That's AB. Now let's find the median when we're looking at segment BC. So if we go back to our picture, now we're no longer looking at that one. We're looking at the median that connects segment BC with the opposite vertex of A. So on the one hand, we're using the midpoint, which is 9/2, comma 5. And on the other hand, we're using point A, which is at negative 2, comma 5. Again, we'll start by calculating the slope. y2 minus y1, over x2 minus x1. But really, this turns out to be a 0. It's a horizontal line. So this problem actually works kind of simply. If it's a horizontal line and it has a y coordinate of 5, the answer is pretty simple. It's just going to be y equals 5. Make sure you're comfortable handling vertical or even horizontal lines. And finally, we need the median involving segment AC. So we'll get rid of this line right here. And now when we want the median of AC, it connects segment AC with the opposite vertex. So what we are using would be the midpoint, which is 3/8, with the opposite vertex, which is B, 1, negative 1. Again, we'll start by calculating the slope, y2 minus y1 over x2 minus x1. In the numerator, we get a negative 9. Denominator is a negative 2. So the slope of this line is 9/2. Take either point. I think the 1, negative 1 might be easier to work with. And we plug into y equals mx plus b. The y is negative 1. The m is 9/2. X is 1. We're solving for b. This will be negative 1 is 9/2 plus b. Subtract the 9/2 from both sides. Use your calculator if needed. And b is negative 11 halves. So this equation would be y equals 9 halves x minus 11 halves. Now we've got the equations of the three medians. So we will form our system of equations. On the one hand, we have y equals 18/17 x plus 43/17. We had that one equation where it was just y is equal to, what was that up there, y equals 5? And our other equation was y equals 9 halves x minus 11 halves. Now same deal, pick the two easiest equations. In this case, it appears to be the middle and the bottom equation. Use the transitive property. Since the left-hand sides are the same, the right-hand sides have to be the same. So 5 equals 9 halves x minus 11 halves. We could go through on this equation. We can multiply both sides by 2 to clear out those fractions. So we'll get 10 equals 9x minus 11. Add the 11 to both sides. Then we have to divide through by 9. Simplify the fraction. We don't want decimals. We don't want mixed numbers. We want improper fractions. You can divide the top and bottom by 3. So it looks like x is 7/3. Now plug in to find the value of y. We should actually know what the value of y is, by the way. It should be 5. So we're going to have our fingers crossed when we plug in here that this actually works out. We're going to take our calculator, and it needs to work out. If it doesn't, then we've made a mistake somewhere. 18/17 times 7/3 plus 43/17. Ooh, it's 5. Good. We don't even need to plug into the middle equation. It's just that y is equal to 5. And in the bottom equation, y equals 9 halves times 7/3 minus 11 halves. We're hoping that's going to be equal to 5 once we plug this all in. So 9 halves times 7/3 minus 11 halves. I've got my fingers crossed. Woo! And it is equal to 5. That's exciting. So we now have confirmed that x is 7/3, y is equal to 5. Therefore, the coordinates of the centroid in this problem would be 7/3, comma 5. So again, stay organized. But if you stay organized, it really shouldn't be that bad. Calculate the equation of each of the medians. And now, that's just like 3 Algebra 1 problems glued together in one big geometry problem. Once you've got the medians, you come over here to the system of equations, solve for x, confirm that the y's are the same, and hopefully you have a wise answer for the centroid.